Hi guys, let's look at density, relative density and upthrust. Today we shall be considering few of the calculations that do come out in examination such as WAEC, NECO, UTME and other certificate examination. Okay, the question on the screen says an empty relative density bottle has a mass of 30 grams. When filled with paraffin, its mass is 70 grams. To calculate the mass of the bottle when it is filled with water, and we have a constant given here, relative density of paraffin. Okay, let's quickly write out the parameters in this question. Now we have mass of empty relative density bottle. Let's call that one M1, and that is given as 30 gram in the question. And we have mass of the bottle when it is filled with paraffin, that is when the bottle is fully filled with paraffin. So let's call that one M2, and that is 70 gram. And I believe we can easily find the mass of the paraffin that we used to fill the bottle. Let's call that one M3. That is mass of just the paraffin, and you agree with me that that one will be equal to M2 minus M1, and that makes our M3, which is mass of just the paraffin, to be 70 minus 30, and that will be 40 grams. Now they ask us to calculate the mass of the bottle when it is filled with water, so we can quickly calculate the mass of the water that is in the bottle, and we can do that by using the relative density of the paraffin. Remember that relative density of a material or any substance is equal to mass of the substance over the mass of equal volume of water. So we can say relative density of the paraffin permit me to just use that as a subscript, equal to mass of the paraffin is M3, and let's say the mass of equal volume of water, call that one M4. Let's take note of all those letters we are using. So mass of the paraffin is given as a constant in the question, and that is 0.8. Mass of the paraffin, which is M3, is 40, and we are looking for mass of equal volume of water that will fill this empty density bottle. So our M4, which is mass of equal volume of water, will be equal to 40 over 0.8 mathematically. That is by making M4 the size of the formula, and this will definitely give us 50 grams. And permit me to just adjust the screen a bit. Okay, having this is the mass of the water that will fill the empty density bottle. So what is now the mass of the bottle when filled with water? Mass of the bottle when filled with water, let's call it M5. So mass of the bottle when filled with water will be equal to mass of the empty density bottle, which is M1, plus mass of the water that we calculated, which is M4, and that will be equal to 30 grams plus 50 grams. So when this bottle is filled with water, the mass will be 80 grams, and that answers question number 1. Okay, let's look at another question here. In this question number 2, the question says the density and weight of a solid are respectively 5,000 kilogram per meter cube and 1 Newton. We have to determine the upthrust on the body and apparent weight of the body when fully immersed in water. That is the density of a given solid is 5,000 kilogram per meter cube, and its weight when it is measured in air is 1 Newton. That is what the question is saying. So we have to find the upthrust that will act on the body when the body is fully immersed in water, and also apparent weight of the body in the water. you all agree with me that when a solid, a substance, or especially a solid, when they are immersed in water, definitely there is apparent weight loss. They experience apparent weight loss due to the upthrust on that particular of that fluid that is acting on them. If you can recall, you know the upthrust is a particle force that is acting in a fluid that uh, makes that cause apparent loss in weight to every object immersed in that fluid. And in this case, the fluid we are considering here is water. Okay, now let's quickly pick some parameters from this question. There's a density of the solid. According to the question, the density of the solid, let's use the symbol of density rho of the solid equal to 5,000 kilogram per meter cube, and we have weight of that solid. Sorry for that. We have weight of the solid to be equal to 1 Newton, and that simply means the mass of this solid, let me put subscript S here, the mass of this solid will be what? 1 divided by 10, provided that our acceleration due to gravity equal to 10, and that will be 0.1 kg. Okay, let me just put this here as a constant. Let's say g equal to 10 meter per second squared. Okay, now we have this information from the question. Now the first question says we have to determine the upthrust, but before we can determine the upthrust, we need to find the volume of this solid, and also consider some other factor before we can find the upthrust. And remember that density equal to mass over volume, and from there we can say our volume will be equal to mass over density. Therefore, the volume of this solid will be equal to mass of the solid over the density of the solid. And from the question, this will be 0.1 divided by 5,000. Let's quickly pick up our calculator and check this out. From our calculator, you can see that the volume of this solid will be equal to 2 times 10 raised to power minus 5 meter cube. Okay. Now, another thing to consider in this question is that the question says we have to determine the upthrust when the body is fully immersed in water. When the body is fully immersed in a fluid, it will displace the fluid that is equal to its volume. Please take note of this. But in some of other questions, we are going to see when the body is when half of the body is immersed in the fluid, which means the volume of the fluid displaced will be half of the volume of the body. Or probably a question may say when the body is immersed up to probably 75% of its size, definitely the volume of the fluid that will be displaced will be 3/4 of the volume of the body. But in this case, the body is fully immersed in water, and that simply means the volume of the fluid, the volume of the water displaced will be equal to the volume of the solid. Okay, now let's calculate our upthrust. Remember that upthrust equal to volume of the fluid. Let me just use subscript F for that, multiplied by the density of the fluid that is in which the solid is immersed, multiplied by acceleration due to gravity. Let me repeat that. Upthrust equal to the volume of the fluid displaced by the body. That is when you put a solid in a fluid, the fluid that will be displaced, that is what this V subscript F is representing. Okay, now rho F simply means the density of the fluid in which the body is immersed. In the case of this question, the body is immersed in water, so we are considering the density of water here. Okay, and acceleration due to gravity is given as a constant. Okay, let me adjust this screen a bit. Alright, now let's get to work. Therefore, upthrust, which is our first question, will be equal to, now the volume of the fluid, which is equal to the volume of the solid, that is the body is fully immersed in the fluid. That will be 2 times 10 raised to the minus 5, and the density of the fluid, which is density of water, that is 1000, and acceleration due to gravity is 10. So if you press your calculator, the value of the upthrust that we are going to have here will be equal to, that will be 10,000 multiplied by 2 times 10 to the minus 5, and definitely that will give us 0.2 Newton. 0.2 Newton. Okay. Now the second question says, this is our first question here. Now the second question says we have to calculate the apparent weight of the body in the fluid. Apparent weight of the body in the fluid, that is what is left in the measurement of the weight of the body when after we've immersed the body in a fluid. And we can easily calculate that as long as we know the weight initially, the weight measured in air, which is WS, and we know what our upthrust is, we can subtract our upthrust from the weight measured in air, and we are going to have the apparent weight, and that will be 1 minus 0.2, and this will be equal to 0.8 Newton. 0.8 Newton, and that's also the question. Okay, let's briefly go through what we have here. We have the density and weight of the solid given in the question. We have to determine the upthrust and the apparent weight of the body when fully immersed in water. The step taken, we first find the volume of the body, and that translates to the volume of the fluid displaced as long as the body is fully immersed in the fluid. And I also explained that if the fraction of the body is immersed in the fluid, that fraction will be the fraction of the volume of the body will be equated to the volume of the fluid displaced. And we calculated our upthrust using the formula volume of the fluid displaced multiplied by density of the fluid multiplied by acceleration due to gravity, and that gave us 0.2 Newton. And apparent weight of the solid, we calculated that by subtracting our upthrust from the original weight of the body, and we have 0.8 Newton. Another thing you need to note here is that sometimes when they want you to calculate the upthrust, they may call it apparent loss in weight in the fluid. That's another name they may give to upthrust. Okay, now if you have any question on what we've done so far, from question number 1 and question number 2, I would suggest that you drop your question as a comment in the comment box, and your question will be attended to. Thanks for watching.